because they're like alternate interior. It's like
So
alternate
yeah,
interior.
so forget about that for a minute. It's much simpler than that. They just meet at an X here. The angles just meet at an X.
Oh, because they're vertical.
Exactly. That's the answer. Yes. So vertical angles. Now, some instructors are really picky. They want correct spelling. They want you to say vertical angles are congruent. They want you to say definition of vertical angles are congruent. Where does your teacher stand? Are they pretty particular or do they not care? What
Just like not like a specific thing, just like vertical.
so saying vertical angles would be enough.
Yeah.
Good, good, very good. Okay. That's good to know because some teachers are really picky and it's kind of annoying, truthfully. All right. So 16 actually leads into 17. And this is one of those things in geometry that students just hate. And I didn't like it very much either. I don't know what to tell you. I mean, everyone has to take this class. What you're saying here in 16 is that the angles are congruent, therefore they have the same measure. And that's weird because it's like, I thought that's what congruence is. No, congruence means they're congruent. Same measure means they're the same. Like if you were to actually literally measure them, they're the same measure. Okay. Any
Mm-hmm.
idea what that is? It's a definition of, but it does have to do with step 16. What type of angles are these? Or
Um,
what are we notice about the angles? What is this symbol in the middle?
it's I don't know.
What's this symbol in the middle? The one with the two equals and a little line above?
I don't know what it's called.
Okay. That means congruence. All right, so this is definition of angle congruence. All right, we're gonna come back to this in a moment here, but I want to just quickly ask you, I'm assuming you've had an English class where you have like a vocabulary list each week.
Yeah.
So this course is actually a lot like that. So if you want to do well in this course, you almost have to come up with note cards or Quizlet or something like that. Like you have to know, like, and so far we've had a couple here. Vertical angles are congruent. You mentioned alternate interior angles. To do well in this class, you have to almost have like note cards, something where you're just constantly looking at these things to be able to know what they are. It's more about the words than the actual math, which may be different. Like you may be used to, oh, just solve the equation, and there's a little bit of that, but with these proofs, it's all about just the right words. All right. So let's go back to 18. It says measure of angle 6 plus measure of angle 7 equals 180. Okay. So sometimes you got to like go back to the drawing to be like, well, where is 6 and 7? So I'm going to drop that here and let's look at angle 6 and angle 7. This is called the transversal. Are these on one side or the other of the transversal?
Um, yeah,
Which one? Are they on the same side or opposite sides?
the same.
Same side. So we would call them same side. Start. Now, are they in the interior or the exterior?
Interior.
So these are same side interior. So these angles are considered consecutive angles on the same side interior. Sometimes teachers just let you use the word consecutive. That means they are right next to each other. And I have no idea what your teacher wants for number 18, but in this case, because they're consecutive, they are supplementary. So I have no idea what property your teacher wants here. Same side, consecutive, something like that would be a good idea.
It's cause like we got this paper and like it has like a list of things and we just have to like we have to like write like one of those like down of what it is.
Sure. And so for me to best help you, the more you send over, the better. Like having that full list would help me tell you what's here because I don't know what your teacher's thinking. And I'm just sort of giving you the general guidance on this problem. Um, Proofs are a lot like art. believe it or not. It's like if you remember in art class, you'd be asked to paint something that they might put up in the classroom, and everybody's artwork looked a little bit different. These proofs are going to vary just a little bit from student to student. All right. So now
Okay.
because these two angles are adding up to 180, okay, you can say that the lines are parallel because of those two angles. Now, the correct, the truly math answer here is some sort of what's called a converse. Have you guys talked about converses in this class?
Yeah.
Okay. So this is if they, so the idea is like if the lines were parallel, then 6 plus 7, the measure of those angles would add up to 180 because of same side interior. Since you don't know that they're parallel, if the angles add up to 180, like we said in the previous line, well, the lines are parallel by the converse of definition of parallel lines cut by a transversal, something like that. Again, without that list, I'm a little bit off here, but this is a little bit different than just the pure like, you know, is it a definition or is it converse? So try to explain it to students this way. So like if two lines are parallel, like let's say S is parallel to T, then then we can say a bunch of things like alternate interior angles and alternate exterior angles and same side and things like that. That's the like typical the definition of in a proof. But when you go backwards, like when you start out with, oh, like I know that the alternate interior angles are congruent or same side interior, consecutive, add to 180, that's the converse. And so in math, there's a lot of problems where you go forward and then backwards. Right? So just kind of a thought there for you. All right, let's take a look at the next one here with this angle relationships. Um, this one's nice. They give you a box to pull from, so there's no guesswork. We can do this. So started with angle 8 and angle 19. So I think it's a really good idea to go identify them on there. Let's see where they are. There's 8. There is 19. So if those are congruent, and I think what would really help is to actually like cut away from all of this, but there's a lot of extra lines here. But if you could imagine here, I'm gonna try and do it down here, that here is L, here is N, this is 8, and this is 19. I think it's a lot simpler to be able to tell me what this is, what kind of angles these are, by removing all the unnecessary lines. What would you say now about these?
Alternate interior.
Alternate interior angles, right? Good. But if you just look at the drawing as is, this might be like, oh my gosh, how do I even find that? So 13 and 15, let's take a look at those. 13, there's 13, there's 15. All right, so this one, sorry for all the scrolling. I'm trying to get where I can see it as well. It's this one, and then these two, J and K, there's 3, and there's 15. And it's kind of a common thing to do in this class to add a line or remove a line. What type of angles are these now?
Corresponding.
Corresponding. Yeah, so that's what, A? All right, good. Now, before we get to the next two problems here, there's kind of two things you're going to do in this course over and over again. You're gonna either going to say, okay, something is congruent, which means they equal each other, or they add up to something. And that something will really range in this course. Like for right now, a lot of things add up to 180. But you've probably also seen things adding up to 90. Later on, it'll be 360. There's a lot of that goes on in this course as well. So I bring that up here because 22 and 23 are two angles adding up to 180. Those are either going to be D or E. It's consecutive angles that always add up. These add up. Whereas the first three grouping, these are congruences. So again, this is more like note card stuff you got to like, I got to write down, got to figure out what it is. So measure of angle 9, measure of angle 21. We're kind of running out of colors here. We'll try get one more in here. 9 and 21. Are those consecutive interior or consecutive exterior?
Consecutive exterior.
They are. They are. And it's good that you can see that. They're on the outside, which means most likely 23 is D. We can do that if we need to. Let's go to angle 4, congruent to angle 23. So I don't know here. Let me go back to this one here. 4 and 23, they're congruent, so it's either A, B, or C. What do you think?
Um, it should be corresponding.
Corresponding. Okay, so let's draw them without all the additional lines here. So it's like this. There's this one, there's this, and then I just lost it. Sorry. 4, 4, and 23. So to me, it's like I don't know how they explained it, but it's like you go into a classroom and you always sit in the back left seat, and then you go into another classroom. Are you sitting in the back left seat?
No,
No, this would be like front right. So to me, that's corresponds. Like no matter what classroom I'm in, I always sit in the same like relative position. So these are definitely not corresponding. What's another possibility for them?
it'll be alternate, like interior.
They're definitely alternate because this is the transversal. And so they're on one side of each other. There's definitely alternate. This is the interior. This is the exterior. How does that change how you want to answer this?
Oh, so it's exterior.
Yes, these are alternate exterior angles, which is letter C. Okay, let's try. I'm just going to throw a problem up in front of you because everything we did so far is like proofs and definitions. I just want to get a feel for some of your algebra skills. Um, this is the kind of problem you may have already seen, or if you're not, you will see them pretty soon. I'm not going to give you any information. Just want to see how you do on something like this. Um, instead of finding instead of finding CE, which we will do, I'd like you to just solve for X. And I go ahead and just take a minute or two and see if that's something you can figure out. If not, we'll definitely work it out together.
Do I find X for C, D, or D, E?
Well, so here's my I'll give you a hint before I answer that question. Draw a picture with C, D, and E in it.
Like, what do you mean a picture? Like a line?
So it doesn't really matter what you draw, but this is C, this is E, and this is D. Meaning like it doesn't matter how long it is, doesn't matter if it's bigger, smaller, whatever. C to D is 9x minus 7, and D to E is 3x plus 17. So if D is the midpoint, what does that tell you about CD and DE?
They're like, they're congruent.
They're congruent, or they equal, yeah. So what can you do with these two expressions if they're congruent?
You could, they're equal to each other.
Exactly. Good. Now, could you try solving this for X, please?
Is it 4?
It is x equals 4. Good. Okay. Let me have you try one more problem here. And so the try it out lesson is about 30 minutes. We'll make this our last question here. Um, we kind of looked at this earlier. Do you remember what kind of angles, what the name of these angles would be when they meet at this x?
Vertical?
Yes. And what do you know about vertical angles?
They're 180.
Nope. They are congruent. 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 Which means that these two angles equal each other.
So do I solve for x again?
Yes, but how do you do that? Like, what is it that you're setting equal?
Like, you do this x plus 29 equals ax minus 5.
Yes, exactly.
Would it be 17?
So x is 17. Very good. And let's just say we wanted to actually find the angle measure. Like, let's say this was like A, B, C, and I wanted you to find the measure of angle A, B, C. What would you do with that 17?
I'd plug it into the 8x.
All right, very good. So go ahead and give that a try. Let me know what you come up with.
Is it 131?
Sounds reasonable. Actually, although, yeah, just looking at this other one. Okay, very good. All right, we're going to stop there for today. Go ahead and stop the recording.